What causes NaN losses during TensorFlow model training? Imagine trying to solve a puzzle, but suddenly the pieces start to vanish or become impossible to fit. That's what NaN losses do during TensorFlow training. When the loss function outputs not a number, it stops the learning process. This usually happens when calculations become unstable or go outside expected ranges. One common cause is using a very high learning rate. If the learning rate is too big, the model makes huge jumps in its parameters, causing gradients to explode and produce NaN values. Complex models with many layers or operations like division, logarithms, or exponentials can also lead to invalid numbers if the inputs aren't carefully controlled. For example, taking the logarithm of 0 or dividing by 0 results in non-proper initialization of weights and biases is important too. If weights start with extremely large or tiny values, the gradients during backpropagation can become unstable and lead to non-data issues are another big factor. Missing values, zeros in places where division or logarithms happen, or unscaled features can cause calculations to break down. For instance, if you try to take the logarithm of 0, it results in NaN. Labels or targets that are outside the expected range or formatted incorrectly can also cause the loss function to output NaN using a loss function that doesn't match the problem type or label format can be problematic. For example, applying sparse categorical cross-entropy with non-integer labels can lead to NaN values. Sometimes, certain layers like pooling or normalization layers produce NaN if their inputs are invalid or if their parameters cause division by 0. The optimizer itself can also be a culprit. If hyperparameters are not set properly, some optimizers might cause unstable updates that lead to NaN. To fix or prevent these issues, start by lowering the learning rate to make smaller, safer updates. Always check and preprocess your data to remove missing or invalid values and normalize features properly. Use suitable weight initialization methods so gradients stay stable. Confirm that your loss functions and metrics match your data and problem type. Monitoring intermediate outputs and gradients during training can help you spot where NaN first appear. Simplifying your model temporarily can help identify problematic layers or operations. Debugging tools like TensorFlow Debugger can trace where NaN originate. Understanding these causes helps keep your training stable and your models learning effectively. This is especially important when developing AI tools like ChatGPT, DALL-E, or Midjourney, where reliable training makes a difference. Many productivity plugins include diagnostics to catch these issues early, making your development process smoother. By systematically addressing these causes, you can keep your TensorFlow models on track and avoid frustrating NaN losses.